Welcome back to PowerMaster's channel. In this video, I'm going to discuss how to choose the right solar charge controller for your needs. Well, we will cover three main aspects: the categories of solar controllers, the important specifications to consider, and the common functions. The primary role of solar charge controller is to prevent overcharging of battery through advanced charging algorithms. The controller monitors battery levels and switches to weak flow charging current once the battery is full, maintaining it at 100%. This function is crucial for protecting battery from damage. On the other hand, controllers can adjust the charging voltage based on battery levels to extend battery life and performance. Now let's talk about the types of solar controllers. First, there are two types of solar controller options: PWM controllers and MPPT controllers. PWM stands for pulse width modulation, which is measured to regulate charging. PWM controllers offer basic charging functionality, decreasing the voltage from solar array to charge the batteries. However, this reduction in voltage comes with power loss, making PWM controller efficiency range from 75% to 80%. For example, with a 1000 watt solar rate, you might lose around 200 watts. MPPT stands for Maximum Power Point Tracking, an automated method to adjust charging compared to PWM. MPPT controllers can achieve maximum power output from the solar array under various conditions. They accept higher voltage levels, reduce voltage to match the battery voltage, and increase current to recover any lost power due to voltage drops. MPPT controller boasts an efficiency of 94% to 99%. In summary, PWM controllers have a price advantage due to their basic structure, leading to lower costs. However, they fall short in charging efficiency, resulting in intermittent charging and higher battery recall. MPPT controllers shine in charging efficiency, with smaller battery recalls and the ability to connect to higher voltage solar arrays. However, the advanced features of MPPT controllers comes with higher cost due to their complex structure. Once you have decided on the controller type, the next step is to match the controller specifications with your module configuration. Begin with the system voltage. Determine the battery pack's charging capacity. Additionally, consider the solar input parameters such as open circuit voltage and the maximum input power, influencing the solar array size. Some solar controllers can connect to DC loads. You can check the DC output parameters to match the intended DC load. For controller charging functions, take into account charging algorithm, charging protection, equalization charging features, IP class, and more. Currently, the popular charging algorithm for charging controllers is the three-stage charging method. This algorithm adjusts charging voltage based on battery charging level to protect and extend battery life. By presetting charging voltage, it adjusts charging current and voltage during the process, ensuring safe and efficient battery charging while maintaining optimum performance. When the battery is full, the algorithm uses the minimal current to sustain the charge. As the battery voltage drops to a preset recharge level, it enters a new charging phase, repeating the cycle. This approach optimizes battery performance and enhances charging safety and reliability. The charging protection function also plays a crucial role during the charging process, ensuring the safety and stability of the entire system. This controller commonly features built-in protective functions, which can serve as reference points for making decisions. A controller with a built-in equalization function can reverse the accumulation of adverse chemical effects, such as stratification phenomenon. Stratification refers to a condition where the side concentration at the bottom of the battery is higher than at the top. Therefore, it is recommended to perform battery equalization periodically. If the connected battery is of the type like lithium-ion or GEL that doesn't require equalization, this function doesn't need to be considered. The IV class refers to dust and water roof level of the controller. In various application scenarios, there are different requirements for the dust and water roof performance of the controller. A higher IV value indicates a higher protection level. For instance, outdoor solid-state lighting systems and maritime optional environments have specific demands for equipment's waterproof capabilities. The choice can be made in conjunction with the specific scenario. That concludes the complete guide to choosing a solar charge controller. If you have any questions, feel free to leave a comment below. You are also welcome to visit our website for more information about Polemister products. Thank you for watching and see you in our next video.